This is lesson 85, the probability of independent events. Now, independent events are events that do not affect each other. You draw a card from a deck of cards, you put it back so that the second time you draw, you still have the same choice of cards. We're going to see coins in a bag. We're going to see fruit in a basket. We've got a cooler with some drinks in it. We just got a variety of problems. And then we'll also look at flipping coins, which do not affect each other, and rolling dice. So we'll look at several different types of things. Let's first look at, let's do number 3. It says, a bag contains 8 red marbles and 3 blue marbles. Another bag contains 7 green marbles and 7 yellow marbles. You randomly pick 1 marble from each bag. 1 marble is blue and 1 marble is yellow. So we're going to draw from our first bag that has 8 red marbles and 3 blue marbles. Now, the main thing for probability is knowing that the bottom number is the total that you have to choose from. And then the top number are the successes, which just simply means what you want it to be. Like in this case, we want that marble coming out of this first bag to be blue. So how many marbles are in the bag? Well, 8 and 3 make 11. And when we reach in the bag and we are successful, we get a blue marble, and there's 3 of them. So we have a 3 out of 11 chance. Of the 11 marbles, 3 of them are blue. Now, when you're doing and problems, and all of these are ands, it's multiplication. So the second bag, they do not affect each other. What you took out of the first bag does not affect the second bag. Another bag has 7 green marbles and 7 yellow marbles. So there's 14 marbles in the bag, and we want the marble to be yellow. So our successes would be the 7. Now, you can multiply like it is, reduce. You've got several ways to go about it. I don't know what kind of calculator you have. On your multiple choice on the lesson, it's going to give you the fraction, but it's also going to give you the approximate decimal. So that's going to help you as you choose your answers. Now, I'm going to do both, and I recognize that I can reduce this 7/14, which makes the arithmetic a little bit easier, especially for the fraction. So I've got 3 times 1 on top, and I've got 11 times 2 on the bottom. Now, some cases they round to 3 decimal places, and some they round to 2. You'll just have to look at your multiple choices as you do them. And when you divide 3 by 22, you actually get 3 divided by 22. And some of these I'll just go ahead and put the answers. But in this case, they actually rounded it to 3 decimal places. Oops, sorry, here we go. And the 3 makes this 6 stay the same. So it's approximately 0.136. Okay. Let's look at number 5. This is a cooler problem. The cooler contains 13 bottles of sports drink, 5 lemon lime, 5 orange flavors, and 3 fruit punch. 3 times, so you're going to do 3 drawings. Oops, sorry. You randomly grab a bottle, return the bottle to the cooler. Now, the reason, and we're going to look at dependent events in lesson 86, but it's independent because when you draw it out, look at it, which is kind of weird, but you put it back in the cooler, then you still have the same number to draw from because we have a total of 13 bottles in the cooler. So every time we have a choice of 13 drinks. You'll see a difference in that when you do what you normally would do is draw it out and keep it, draw another one and keep it. But we'll show you the difference in those. But each time you're putting it back, return the bottle to the cooler, and that makes it independent, and then mix up the balls and draw again. So the first time, first time we have 13 in there, and we get a lemon lime. So how many of those 13 are lemon lime? 5 of them. Okay. Put it back in. Stir them up. Second choice of the 13, and we want it to be a fruit punch. So of the 13, 3 of them are fruit punch. And then we put it back in. We draw the fruit punch again, which is 3. Now this one does not cancel at all. So you just multiply across, And it's really easier to just do the top and the bottom separate instead of trying to multiply the fractions. Just do 5 times 3 times 3, which is 45. And 13 times 13 times 13 is 2,197. And then as a decimal, they rounded that to 2 decimal places. Sometimes they do 2, sometimes they do 3. I'm not sure I know the consistency of why they do what they do. Okay, and this one, they're independent. We're going to flip a coin 4 times. And every time you flip a coin, you get heads or tails. You flip it again. The second to the first time did not affect the second one. It could still be heads. It could still be tails. And then we're going to roll a fair 6-sided die. And that's what you're used to. It's just one of a pair of dice. And we're going to do that 3 times. So we're going to do coin 4 times. And then we're going to do the die 3 times. Okay, just about run out of room. So the coin lands heads up every time. We're going to do that 4 times. So how many choices? Heads, tails. You only have 2, and a success would be heads, which is one of the 2. And we do that every time. 1/2, 1/2, 1/2, 1/2. One of the 2 is heads up. Now let's do the die. Well, a 6-sided die has the little dots on it, and it has 6 choices. 1, 2, 3, 4, 5, 6. And we're rolling them. We roll it, look at it, roll it, look at it. So each time we have 6 choices. They're independent of each other, and we want an even number. Well, you've got 1, 2, 3, 4, 5, 6. 2, 4, and 6 are even. So 3 of the 6 are even. Again, 3 of the 6 and 3 of the 6. Now, if you recognize that you can reduce these to 1/2, that makes your arithmetic a little bit easier because you're just multiplying 1 on top and you get 1. And then you're multiplying 2, 1, 2, 3, 4, 5, 6, 7 times, and that is 128. And then they did this one, and I say y to 3 decimal places because it's going to go 0.008 approximately. Okay, we haven't done the basket. Let's see, I've got a couple of different basket problems. Let's do number 10. A basket contains 4 apples and 5 peaches. 3 times you randomly select a piece of fruit, put it back in the basket, and then mix the fruit. All 3 times you get an apple. Oops, sorry, there you go. So we're going to draw 3 times. And they didn't tell us, but there's 9 pieces of fruit in the basket. 3 times you randomly select a piece and put it back. So 9, look at it, put it back, still 9 to choose from, still 9 to choose from. Every time it's going to be an apple. So 4 of the 9 are as an apple. Again, 4 of 9, and again 4 of 9. And then 4 times 4 times 4 is 64. 9 times 9 times 9 is 729, and that is approximately 0.088.